Okay, so welcome to this video where we are going to solve a question based on dynamics, and basically this is dynamics on the incline. So the question goes like this. We are saying a 400 kg mass on a 30 degrees inclined plane is acted upon by a force of 480 newtons at an angle of 30 degrees with the incline as shown. Find the acceleration of the mass if the surface has the coefficient of kinetic friction of 0.2. So some people, they normally make mistakes on this question and they end up getting it wrong. Why? Because most of the times they think that a force can't be raised at an angle like this on the incline. Hence, they normally think to say the force can just be acting in this direction. So for this type of a question, we have to be so attentive because there is a trick here. All right, so we try to draw a free body diagram for this question. How will it look like? Okay.
408 ati danse ishupile paseti dansile koseka veji dansile itotishane fedede kwatapa epulani elamune be yourself ekunyantililo yosekesho mupashino tifyongoni oyo mulange kwese kufumina madansi chimwe madansa before they get dance
All right, so if we come here now, it seems like we are done with the free body diagram. All the forces here that are there now. All the forces here that are there now. So the thing is, we need to know what to do next whenever you want to calculate this same question. What are you supposed to do? So remember, this surface is going to be taken to be my x-axis, and then the one which is going to be in this given direction has to be what? In a form of y-axis. I'll just take back to the introduction that we had. If something is like this, you raise this one at a given angle like this to be the force. I know that we are going to resolve this one into its components. We are going to have F cos theta based on the angle here. This one is going to be F sine theta, meaning that the normal force is going to point in this given direction and the weight force is going to point in this given direction. Friction is going to point in that given direction. I remember we said for you to understand to say what would be the normal force here. What would be the normal force here? We said the summation of forces in y must be equal to 0. Reason being the forces are not, or rather the object is not moving in the y-axis. Hence, it just moves in the x-axis pointing in this given direction like this. So if you do it like that now, for you to understand to say what would be the normal force, we're trying to have the normal force at this moment of time because I need to understand that it is the only one which is related to what we call the friction force. So the summation of these two forces has to be equal to the summation of downward forces. I'll say N plus F sine theta, it must be equal to mg. If the force has been acted from this given point, we understand that always normal force has to be equal to the weight force. Now in this case, we don't consider the normal force to be equal to the weight force because we have the component which is made by that given force. So here the force, the normal force is going to be equal to, you say mg. This one can go to the other side. We are going to subtract and we'll have F sine theta. This has to be the normal force whenever a force has been acted at a given point trying to pull the object. Same applies to this one also, but you have to know that the normal force here is going to be equal to that one. In short, the summation of upward forces must be equal to this one. Okay. Okay, I hope everything is just clear. Now we can follow up the process now. Remember, the acceleration for this one is pointing in this given direction. It has to be pointing in this given direction based on what you have in front. So what force makes this object move forward? It has to be the force which is parallel to the incline. The meaning of parallel, it faces either in the same direction or it is facing in the opposite direction, but they must not meet at a certain point. All right, so for you to easily understand to say what will be the thing here, I've already done it to say the summation of forces in y-axis must be equal to 0. Now I'll say the summation of forces in x-axis has to be equal to acceleration. It has to be equal to ma because the object is moving in the what? In the direction of this same incline. Don't get confused to say this angle which is here, it is the one which we are going to use to resolve that one. There must be cases sometimes, or there are cases sometimes they can even give you 20 degrees here. Meaning that if they give you 20 degrees there, this one which is here, it must carry 20 degrees. Let me try to write these forces. I was saying 480, oh, sorry, 4,800, say cos 30 degrees, and the other one, this one has to be for x, then for y has to be what? 4,800 sine 30 degrees. All right, so meaning that the one which is making this one move like this, it has to be this given force, which is going to be that one. But the meaning of summation of forces in x has to be equal to that. It means the forward forces has to be, or the summation of forward forces has to be subtracted by the opposite forces. So these forces that are moving in the opposite direction, they are called opposing forces. What are you supposed to do now? You are going to understand it fully to say we are going to have friction force and the component of mg, which is also pointing in the opposite direction. Okay, so to easily understand this question, this is the force which makes the whole system move forward. It has to remain somewhere here, or it has to be taken at this given point. 4,800 cos 30, say minus the friction force, say minus friction, minus the component of that same force, so say mg sine 30. Reason being because these angles are almost the same, that's why we're using the same angle. I'll say equal to ma. I'll say equal to ma. So remember, we want to get the acceleration, just divide throughout by m, and also here I'll do likewise by dividing throughout by what? By m. Okay, like this. All right, so I'll say divide by m. I'll cancel this, meaning that acceleration is going to be equal to, so if you punch this on the calculator, we are going to get the following answers. Okay, so punching this on the calculator, if you say 4,800 cos 30, what answer are we getting? We are trying to get, we are getting 4,156.92 minus. But you need to be very, very careful when it comes to friction force. I want to demonstrate how friction force is going to be related to the normal force. We know that friction force has to be equal to mu normal. This has to be the coefficient of kinetic friction. But remember what I said? I said the summation of upward forces must be equal to the summation of downward forces. What does it mean if you write it like that? From this demonstration, which I'm from showing here, you find that if you add this plus that, we are going to equate everything to what? To the downward force, which is going to be this one at this moment of time. Remember, we're taking this one to be our surface. So meaning that these forces acting in this given direction, the forces in y-axis. Okay, let me try to demonstrate it somewhere down here. We are going to have the summation of forces in y. The summation of forces in y must be equal to 0 because we don't have acceleration, or we don't have motion in y. So we are going to have normal plus the component which is given here. In this case, I mean this given component. I'll say 4,800 sine 30. I'll equate everything to the downward part. The downward part has to be mg, I'll say cos 30 degrees. So this one can go to my left hand side. I'll say normal is going to be equal to mg cos 30 minus, and we are going to have 4,800 sine 30. So we can do calculations here. Normal force is going to be equal to, you place your 400 somewhere here, multiplied by 9.8 cos 30 minus 4,800 sine 30. Let me try to do calculations just quickly. I want to do calculations for normal force here so that we can place it somewhere here. Then we find the friction force. We are going to replace it where there is friction, including this one. We are going to do it like that. Okay, so I'll start with this one. I'll put everything inside the brackets. Now then 400 multiplied by 9.8, that is cos 30. I'll close and I'll say minus. This one has to be say 4800 sine 30. So definitely we are getting the answer for friction force, for normal force as what? We are getting this answer as 994.82. So meaning that friction force is going to be equal to, what is the coefficient of kinetic friction that you've been given at this point? It has to be what? 0.2. So I'll say 0.2 multiplied by 994.82. So our friction force is going to be equal to, okay, all right, so I'll say 0.2 multiplied by 994.82. What answer are we getting? We are getting our friction force as 199 newtons. So this is what you are going to replace where there is this part for friction, 199. Say minus. If you come on this case, you'll find that we can also replace where there is mg. So I'll say mg sine 30. It has to be equal to, what is the mass? We have 400 multiplied by 9.8 sine 30. You can also punch this on the calculator. We are getting 1000. So here we are getting 1960. So we are getting 1960. Now say divide by the mass, which is 400. Acceleration is going to be equal to, so to do it easily, I'll just add this and that, then I'll subtract from where, or let me just do it direct. I'll say 4156.92 minus 99 minus 1960. So we are getting this one, then I'll divide this by 400. And the answer that we are getting is 4.99. Whenever you round off this, you are going to get 5 meters per second square. And this qualifies to be the acceleration that the object had as it was moving. Thank you very much for watching. Do not forget to share the video, like the video, and also try to comment for more videos. I'll drop a question for you so that you can also try to answer it. Thank you once more.